Determining whether a function is even or odd and looking at its symmetry is very important. Suppose I want to talk about an even function. Well, for every value a, if I plug in negative a and get the same functional value, then I say that this function is even. And I can also say it has symmetry with respect to the x-axis. This is a function y equals x squared. And you can see if I put in negative x, I get the same value. So if I come up here to 1, let's see if I can get up here. 1 squared is 1, and lo and behold, it doesn't, well, that doesn't look very even, but that's okay. Now, functions are odd have the characteristic that if I put in negative a, I get minus f of a. So this is y equals x cubed. If I put in negative x cubed, I get negative x cubed, and this is negative y. So for this one, if I put in 1, I get 1, and if I put in negative 1, I get negative 1. We say these are symmetric with respect to the origin. So let's look at this function right here, x to the 4th plus x squared plus 1. Is it even or odd or neither? Well, you always put in f of negative 1. F of negative x, and see what you get. So negative x to the 4th minus negative x squared plus 1. Well, this is just x to the 4th minus x squared plus 1. And this is exactly f of x, and so this is even. What about this function? F of x is x cubed minus x. Well, what is f of negative x? Well, this is negative x cubed minus negative x. So this is minus x cubed plus x. Now, my leading sign is different, so I'm going to factor it out. So this is x cubed minus x. But look at this. This is minus f of x. So by our definitions, this function is odd. Okay, let's try this one. Let me plug in f of negative x. I have negative x quantity cubed minus negative x squared plus negative x plus and minus 1. So this is negative x cubed minus x squared minus x minus 1. My leading coefficient is negative, so I'm going to factor it out. X cubed plus x squared plus x plus 1. Now this does not equal f of x. This does not equal minus f of x. So this one is neither even nor odd. Now sometimes we look at the symmetry with respect to the axis or the origin. If I look at the symmetry with respect to the x-axis, I plug in y with negative y and see if I get the same function. To look at symmetry with respect to the y-axis, I replace x with negative x and see if I get the same function. To see if I have symmetry with respect to the origin, I plug in both negative x for x and negative y for y. And for these, you're always seeing, do I get the same function? All right, so let's look at this one right here. X squared plus xy plus y squared equals 0. Now, this is an implicit function, and we'll use these quite a bit. So with respect to the x-axis, let me do this one in blue. I'm going to plug in, for every y, I'm going to put in negative y. All right, so this becomes x squared plus x times negative y plus negative y squared equals 0. So this is x squared minus xy plus y squared. This is not the same function as, same equation as I started, so no. It is not symmetrical with respect to the x-axis. Now let me look at symmetry with respect to the y-axis. All right, for that, I'm going to take every x and replace it with negative x and see if I get the same equation out. So this is negative x squared plus negative x times y plus y squared equals 0. So this is x squared minus xy plus y squared equals 0. Again, it's not the same, so no, I do not have symmetry with respect to the y-axis. Well, this is a bummer. Let me look with respect to the origin. With respect to the origin, I replace x with negative x and y with negative y. Now, let me see if I get the same function. So this is negative x squared plus negative x times negative y plus negative y squared. Does that equal 0? Let's see. So I get x squared plus xy plus y squared equal to 0. Now let me look back up here. That is exactly my original function. So this is symmetric with respect to the origin.